All right, so let's move along and try another example. Okay, so what percentage of meals have 1405 calories or more? So again, we have our same distribution. So X this time is 1405. We know mu is 1070. We know sigma is 300. So we have all of our same values. Again, 1405 we know is going to be over here someplace. And we want to know what is greater than this, 1405 or more. So let's start by converting 1405 to a z-value. We'll see what we end up getting here. So when I worked through this, I got approximately 1.1. Again, it's important to show your work. It's important to round to exactly one decimal place when you're working with z-scores. Now we want to go to table B. Let's look up 1.1. It's down here, 86.43%. So we'll go back here. Let's write this down, 86.43%. Now this is not the final answer. Hopefully you know why that's not the final answer. And that's why I think it's always super important to draw the distribution and shade the area that you're looking for, because I can clearly see that this is not 86.43% of the distribution. It's much smaller than that. And so remember, the table always gives us what's less than. So 86.43%, that's what's less than 1405. We want what's greater than that. So to find that, we just take 100% minus 86.43%. And that's going to give us approximately 13.57%. So our answer is 13.57. And then again, the rule is that when you're looking for something that's more than or greater than, you convert to z, you go to table B and find your percentile, and then you have to subtract that percentile from 100% to get the final answer. So the first two questions we did, again, these were those forward normal problems. So we did a couple of examples of those where we start with X and we're working forward to end up with the percentage or the percentile at the end. Now, this would be a perfect example of a backward problem. If a Chipotle meal falls at the 20th percentile, what is the amount of calories it will contain? So we want to know what X is. Right now we don't know that. We want to know what X value cuts off the lower 20% of the distribution. So remember that a percentile, if you're given a percentile, if something's at the 20th percentile, that means 20% of the distribution would be less than that value. So we want to find a value. It's going to be between these two values somewhere, something in here, that's going to cut off approximately the lower 20% of the distribution. So what is that number? So to help us, what we do, first of all, we have to start off by going to table B. And here is where it would be nice to remember that formula. So X equals mu plus z times sigma. So this is an important formula. So we have mu, we know that's 1070. Sorry about my writing here, I know it's atrocious. Sigma is 300. So we have mu and sigma. We need to find z now, and once we have that, we know we could solve for x. So what I always do is I start and I jump into the table. We want to look for a z value or a standard score that is at the 20th percentile. Now you're probably not going to find exactly the number you're looking for. So we don't see exactly 20% in here. Take what is closest. So you'll see one value we have is 18.41, another is 21.19. It turns out that 21.19 is a little bit closer to 20 than 18.41, so I'm going to take that as my percentile here. So we're not going to get the most precise answer, but we're getting as precise as we can with the tools that we have available. Negative 0.8. So negative 0.8 is going to be my my z-score. So I'll go back here now, and x equals 1070 plus negative 0.8 times 300. And so you can see, or if you work through this, and what I would do first is I would figure out this little chunk, and then I would add that to 1070. You should get x of approximately 830. And again, this is why it's super important to show your work. Now, let's say that you had done this, and instead of taking negative 0.8, you took negative 0.9. That's certainly okay. You know, both of these are in the range of giving us a percentile close to 20. So again, what's really important is that you just show your work. We know where your numbers come from, and that we feel like your solution to this was reasonable and demonstrates an understanding of the big ideas. A meal that has blank calories cuts off the top 15% of the calorie contents of Chipotle meals. So we're looking for the top 15%. What number cuts off the top 15%? So again, here's my distribution. I know that that number is probably going to be over here somewhere. So I want the value that cuts off the top 15%. What would that be? Well, this one's a little bit more challenging because, again, you're looking for the top 15%. And remember, if we go to the table now, so I'm just going to quickly go back here. The way the table is set up, it always gives you what's on the bottom. So it always gives you what is less than a particular value. So whatever cuts off the top 15% would cut off the bottom 85%. So what we have to do is we have to go into the table and we have to find whatever percentile is as close as possible to 85%. And as you're looking here, again, we don't see 85% exactly. I see 84.13, I see 86.43. 84.13 is a little bit closer to 85% than 86.43. So I'm going to take this. I'm going to take the z value of 1. So x equals mu, or 1070, plus z, which is 1 in this case, times 300. So x is approximately 1,370. So I'm hoping that this makes sense. So the value that cuts off the top 15% is the same value that cuts off the lower 85%. And we always have to go into the table and look for what's lower than. So anytime you have a problem where we're asking for the top, a certain top percentage, you have to actually think about what would be less than that. And here's another quick example that hopefully will solidify this idea a little bit more. So if a meal is at the 95th percentile, this means that 5% of the meals have calorie contents greater than that meal. And it would mean that 95% are less than that. Approximately how many calories would a meal need to be at the 95th percentile? So I wanted to do this particular example for you because, again, we're trying to find the top 5% here. What value cuts off the top 5%? And you might see this 95% and you might think, oh, maybe I could apply the empirical rule here because I know in the middle we have 95% of our values. And I could see why you would think that. But remember, if we have 95% in the middle, that means we have 5% left over that gets evenly divided into each tail. So you'd have 2.5% on the bottom and 2.5% on the top, not 5%. So we need a value where there's 5% on top and 95% would be below it. So a total of 95% here and then 5% here. So again, we need to go back to our table, and hopefully you're knowing what we need to do now. We need to find that value that cuts off, or that's roughly at the 95th percentile. So that has 95% less than at 5% above. And this is again a case where you're going to go to the table. You're not going to see 95% exactly. We have 94.52 here. We have 95.54. I would say take either of those. I prefer taking the one that's a little bit closer. So 1.6 is a z-value that's, or 94.52 is a little bit closer to 95 than 95.54. So I'm going to take 1.6 as my z-value. Again, x equals mu plus z times sigma. So x equals 1070 plus 1.6 times 300. And so again, please check my work here just in case I made an error somewhere along the way. And so I believe that this should equal approximately 1550, but let me double check my calculations here just to make sure that's correct. Okay, so that's right on. So hopefully now you have a sense of how to answer these problems if you're given a percentage or a percentile and you have to work backward to solve x. If it's still not making sense, please let us know because we can try to work through some extra practice problems with you. Now, the other kinds of problems you will need to have an understanding of is how to answer a question where you have two values and you want to find the percentage that is between these two values. What's between 500 and 900? So, how do we answer these kinds of questions? I would find, so 500 is here, 900 is over here, we want this percentage. How would we figure that out? So we convert both values to z, that's the starting point, based on our means and standard deviations. So if you do that, when I did that, I got negative 1.9 as a z, and then down here I got negative 0.6. So that's our starting point. Then what we do is we go to table B and we find the percentiles that correspond to each of those z values. So for negative 1.9, it was 2.87. And then for negative 0.6, it was 27.42. And then what you do is you subtract the lower percentile from the upper percentile, and that's going to give you 24.55. So let me say that again. I think I said that wrong. You subtract the smaller percentage from the larger percentage. So 27.42, that's this whole area. 2.87, that's this. If we want to know this, then we just take the smaller and subtract it from the larger. So our answer here is about 24.55%. So anytime you have a problem where you have to find a percentage between and you cannot easily use the empirical rule, you convert each value to z, each value of x. You go to table B, find the percentages or percentiles that correspond to each of the z-scores, and then you subtract the smaller from the larger. That's always, always, always what you do when you have a between problem. So let's practice this one more time just to make sure we're all on the same page. What percentage of meals, sorry about my grammar, ordered at Chipotle restaurants have between 800 and 1705? Again, let's convert both. And I'm just, I really like to draw things just because it helps me gauge whether my answer seems to be in the ballpark. So clearly I'm going to have a pretty large percentage here. So 800 minus 1070 over 300. And then let me go over here where I have a little bit more room. So z equals 1705 minus 1070 over 300. So in this case, I'm going to get, here I get negative 0.9. Over here, I get a z value of 2.3. 2.3 corresponds to a percentile of 98.93, I believe. Let me double check that. Yep, so 98.93. And then up here, the negative 0.9 corresponds to a percentile of 18, excuse me, 18.41. So again, I apologize for my writing, but 98.93% minus 18.41% is going to give us our final answer, which is going to be 80.52%. So please, again, just double check my work. Let me know if you notice any errors. But this is actually my very last slide. So I'm hoping that all of these examples are helpful to you. If you want to see even more, or if things are just still not clicking or not making sense, please let us know so that we can help you going into the midterm exam. So thank you, everyone, and I wish you well, and I'll see you again in the next video.